So question 8, part A, solve the pair of simultaneous equation y squared plus 2y plus 11 equal to x, x equal to 5 minus 3y. So certainly we can substitute x equal to 5 minus 3y into equation 1, and we'll call this equation 1. We'll call this equation 1, this is equation 2. So substitute this into equation 1, so y squared plus 2y plus 11, and now x is equal to 5 minus 3y. So we're going to group, so y squared plus 2y plus 3y, that's 5y, and 11 minus 5, that's positive 6. So we can factorize, so we can rewrite 5y as 2y plus 3y, or vice versa. So we factor by groups, we end up with y plus 2 plus 3, y plus 2 is equal to 0. So y plus 2, y plus 3 is equal to 0. Equate both brackets to 0. So y equal minus 2, y equal to minus 3. And then remember, x is equal to 5 minus 3y, so we can get the value. We can get the values of x. So x was 5 minus 3y, right? So x would be 5 minus 3 times minus 2. So it becomes 5 plus 6, which is 11 here. And y is minus 3. X is equal to 5 minus 3 times minus 3. This becomes 5 plus 9, and that's 14. A function f of x equal 4x squared minus 8x minus 2. We're asked to write it in the complete and square format. So, of course, so f of x, so it's 4x squared minus 8x minus 2. To get it in the complete and square format, we factor 4. So we factor out 4, we're left with x squared. Dividing each term by 4, we have minus 2x. Divide this by 4, we have minus 2 over 4, which is a negative, which is minus half. Now we can complete the square, so this is x minus half of this value here, which is 1, minus the square of this value, which is minus 1, and then we have a minus half out here. So we have 4. We can redistribute the 4 now. So we times each term in the square bracket here by 4. So 4 times x minus 1 all square. 4 times minus 1, that's minus 4. 4 times minus half, that's minus 2. So this is now 4 x minus 1 square minus 6. So this would be the expression or the function in this form. The a would be 4h minus 1 k minus 6, which means the minimum value of the function is negative 6. Equation of the axis of symmetry is x equal 1. Notice this value makes a bracket 0. Now in part C, we have a speed time graph, not drawn to scale. Determine the acceleration of the car for each of the following stages of the journey. Alright, stage 2, the acceleration was stage 2. Notice what stage 2, the speed is constant, so the car is not accelerating. So the acceleration is 0. Because remember, acceleration means change in speed. The speed is constant in stage 2. In stage 2, the speed remained at 12 meters per second. So there's no acceleration, meaning the acceleration is equal to 0. Now we're also find the acceleration at stage 3. And by the way, meter per second square. Right? For stage 3, the acceleration, of course, is change in speed upon time taken. Notice it's the speed, the final speed. The final speed was 0, and the initial speed was what, 12? Upon the time taken was 8 seconds, went from 32 to 40, so 8 seconds. So it's minus 12 divided by 8, that's minus 1.5, right? Meter per second square. And of course, the negative value means the car is slowing down, the speed is decreasing. Question 9 is a circle theorem problem. So we're asked to write down the mathematical names for the straight lines BC and OA. So BC, of course, we'll call it a chord. So the chord is a line that runs from one point of the circumference to another point on the circumference. And OA is a radius. The radius is a line that runs from the center of the circle to anywhere in the circumference of the circle. Next, we were asked to find the size of angle X and the size of angle Y. Now, the first thing that jumped at me here was, notice BD. BD represents the diameter of the circle here. Since O is the center, so angle formed from diameter, of course, is a right angle. So this angle is a right angle, of course. Alright, angle C is here is a right angle, 90 degrees. So angle Y, so notice angles in a triangle add to 180. So when you add angle C plus 49 plus Y, the sum should be equal to 180 degrees. So angle C, and angle by the angle C is 90 degrees, right? So this 90 plus this 49 plus this angle Y should give us 180. So that's what, 139 plus Y is equal to 180. And if you subtract 139 from both sides, Y is 180 minus 139, which is what now? Y is 41 degrees. So the value of Y is 41. The other thing that's noticeable, notice that OB is a radius, OA is also a radius, so which means that triangle OBA is an isosceles triangle. So OB is equal to OA. So if these sides are equal, then the opposite angles are equal. So this angle will also be 37 degrees. Alright, so angle X. To get angle X, notice again it's a triangle which all the angles must add to give 180. So 37, that's this 37 plus this 37 plus X should be equal to 180. And what's 37 plus 37? 74 plus X is equal to 180. So X would be equal to 180 minus 74, which is 106 degrees. So X is 106, so this is 106 degrees. Part B, we have a diagram here and we're asked to find the value of W. Now, angles in a straight line add to 180. So if this angle is 133, then this angle is 180 minus 33, which would be 47 degrees. and it's alternate to this angle, so this angle would also be 47 degrees. And again, angles on a straight line had to give 180 degrees. So 47 plus 56 plus double should be equal to 180 degrees. Now what's 47 plus 56? 103. So angle double will be 77. Next we are asked, right? So the bearing of P from Q, distance RP. Now the bearing of P from Q, which angle are we talking about? So the bearing of P from Q, so it's from the north of Q to the line leading to P. So that's the angle we want. Let's write out the bearing of P from Q. That's the angle there in blue. So notice here to here, that's 180. Plus we just found angle double to be 77. Plus this angle, which will be 56. So we sum these angles and we end up with 313 degrees. Next, we are asked to find the distance RP, and of course we can use the cosine rule for this. So the cosine rule, we use RP, so RP square is equal to the other two sides square, which will be 210 square plus 290 square minus 2 times the product of 210 and 290 cos the angle formed by the 210 and 290 kilometer, which would be 56. So which means that RP square is equal to, you can use your calculator to do this calculation, 60,090, which means that RP would be the square root of 60,090. So the length of RP would be 245 kilometers. So question 10a, the matrix transformation 0p q0 maps the point R onto our image as shown in the figure below. And here's the figure. So we can see the matrix maps R to our image. Notice R, if you can point out what the R is a point 2 minus 5. Notice our image is a point 5, 2. So we wanted the question asks us to determine the values of P and Q. So notice the matrix maps P, maps R to the matrix, maps R to our image. Now the matrix was what? Matrix was 0p q0, and the coordinates of R were 2 minus 5, and the coordinates of our image Coordinates of our R image were 5, 2. So we're asked to find the values of P and Q. Let's do the matrix multiplication. We multiply 0P times 2 negative 5. We get 0 times 2, which is 0, plus P times minus 5, that's minus 5P. And that's equal to the top value here, which is 5. Let me just do the multiplication. And apply the second row to the column. So it's Q times 2, that's 2Q. Plus 0 times minus 5, so plus 0. So if we equate, we end up with minus 5P equal to 5, which means that P is equal to minus 1. Divide both sides by minus 5. And end up with 2Q is equal to 2. Divide both sides by 2. So Q is equal to 1. So P is equal to minus 1 and Q is equal to 1. Next, we're asked to fully describe the transformation M. Let's look at the transformation again. Now you'll notice the relationship between R and R image. If you should measure this angle there, this angle would be a 90 degrees angle. So the rotation is a rotation. So the transformation M. So M represents an anti-clockwise, or I could say counterclockwise, (90 degrees) rotation about the origin, which is 0, 0. So in part B, we have a parallelogram. So PQ, of course, SR would be the same since these two vectors are parallel. So this would also be U. And QR would also be the same as PS, V. And we are told that QM, the ratio QM to MS is 1 to 2. So QM to MS is 1 to 2. So QM would be a third. Now this QM would be a third of QS. Now, write in terms of U and V an expression for QS. So QS would be equal to, using the triangular vector, we could say QS would be QU, QP. So QS, Q to P, then P to S. So QS, Q to P, and then P to S. Now Q to P, notice the direction is different. So it's minus U, direction change, so it's sign of the vector change. And the PS, same as what we have here, V. So minus U plus V would be your solution there. Next, we're asked to find the vector QM, and notice we mentioned earlier, QM is, notice, let's go back to the diagram. QM is 1/3 of QS. So QM is 1/3 of the vector QS, which means that QM is 1/3 minus U plus V, since QS was minus U plus V. Next, we're asked to show that MR is 1/3 U plus 2V. Let's find MR. Now to get MR, we can go M to Q. So MR would be, right? So to get MR, we can go Q to M, M to Q, and then Q to R. So MR, let us do it up here. So MR is equal to MQ plus QR. Now MQ, what is MQ? We just remember QM, we just found QM. So MQ would be the negative of that. Remember QM? Let's remind you of what QM was. QM was 1/3 minus u plus v. So mq will just change the signs, right? So it's negative 1/3 minus u plus v. Plus qr. Qr is v. So we distribute, so negative 1/3 times negative u, that's positive 1/3 u, minus 1/3 v, plus v. No, so with the 1/3 u, now what's negative 1/3 plus 1? That's positive 2/3, so 2/3 v. So if we factor out 1/3, we'd end up with u plus 2v, which is what we're asked to prove. So mr is actually 1/3 into u plus 2v. Remember, this was what we were asked to prove. Next, we're told that T is the midpoint of PQ. Prove that R, M, and T are collinear. Now the term collinear just simply means that all the points lie on the same straight line. So if 3 points are collinear, these 3 points lie on the same straight line. So we have T is the midpoint of PQ. So prove that R, M, T are collinear. Let's go back to the diagram. So T is the midpoint of PQ, so T would be somewhere here. And we are asked to show that this T, R, M, T all lie on the same straight line. Which means that if we can prove that we just found MR, so if we can find the vector RT and show that these two vectors are parallel, it means that they lie on the same straight line. So we know what MR is. 1/3 into u plus 2v. Let's find the vector TR, sorry, the vector TR. We have MR, let's find TR and show that these two vectors are parallel. So TR, vector TR, and what is the vector TR would be TQ plus QR. So TQ would be half of u, since T lies in the midpoint of PQ. So TQ would be half of u. And QR of course would be v. Now notice the relationship between TR and MR. If you should multiply TR by 2/3, you will end up with the vector MR. That's the relationship between these two vectors. So 2/3 times this vector, TR, will give you the same vector as MR, which means that TR and MR are parallel to each other. Hence, T, M, and R are collinear.